In this video, we are going to talk about the conservation of energy and how it can be applied to calorimetry. Now, the first law of thermodynamics simply states that energy cannot be created nor can it be destroyed. So, this really is the law of conservation of energy. So, we can use calorimetry to determine how much heat is released when something undergoes combustion. Bomb calorimetry is a way to measure how the temperature is going to change when water is surrounding the chemical reaction, the combustion reaction. So this is a bomb calorimeter, if you will, here. You have your substance in a dish down here that is getting ready to burn, and then you can light it on fire. Now, this container is closed to the surroundings, and as it burns, it's going to release heat into the surroundings, which is water. And you can see how the temperature changes as a result of burning. This is a really common way that we get the calories in our food. Now, the energy, since it cannot be created nor can it be destroyed, the energy that is lost plus the energy that is gained must equal zero. So if we go back to our bond calorimeter, the energy that is produced by this reaction, so the energy that is lost to the surroundings, is going to be gained by the water. It has to go somewhere. So numerically, those are going to be the exact same number. However, mathematically, they are going to have the opposite signs. So the heat that is lost is going to be equal to negative heat that is gained. So the amount of energy that is lost by one substance is going to be equal to the amount of energy that is gained by another substance. So this negative sign is simply directional, whether heat is being absorbed or heat is being released. When you are undergoing petroleum refinement, we have different types of liquids. So, a flammable liquid, it can support combustion at a temperature that is lower than 37.8 degrees Celsius or 100 degrees Fahrenheit. A combustible liquid is going to be where it supports combustion at a temperature that is higher than 37.8 degrees Celsius or 100 degrees Fahrenheit. When you're looking at hydrocarbons, and that is what we use for gasoline, a lot of times they exist with many more carbons than what we need for gas. So for gasoline, we need something between C5 and C12, which means we need 5 carbons, anywhere from 5 carbons to 12 carbons. And most of the time, when we find these hydrocarbons in nature, they are much larger. So the process of crude oil refinement is a technique that we can use, and it separates the different hydrocarbons based on their boiling points. And so it's very important that you know these different, whether it's a flammable liquid or a combustible liquid, so you can help determine how to best separate them.